Sure. Well, 63. But I guess we can start. What do you think?
I think you can probably start, yeah.
Yeah. So thanks everybody who joined. I'm Dominic. We haven't met so far in the lab, but you already have met Puk and Ani and Anatoly. But together we will give you an introduction today to the virtual replacement for the Pharma practical. Before we start, I wanted to give you some quick information. So I also speak German, so in case you have any questions or doubts and you're not comfortable asking in English, you can also ask in German, and we will figure something out. Don't let language be the barrier. On another note, you all have done the introduction by Anders, right? So how did it go so far with the Google Colab? Were you all able to do the exercises? Were you comfortable with Google Colab? How did it go out? Maybe just write something in chat. Maybe quick yes, no, ja, nein, vielleicht. Something would be cool. Shit. Now the chat is gone. I have too many screens here. Yes, the work was okay, went well. Oh, cool. So at least that worked out. So that's good. So to start, I want to give you a quick overview of what these exercises are about. So roughly speaking, you can separate it similarly to the wet lab practical. So you have a qualitative analysis encompasses one exercise. This is the part that I prepared for you, and you already did something like this in the wet lab, but now you can try to do it in a virtual way. And the other part encompasses the quantitative analysis. So some kind of acid-base titration. That's the part that Puk prepared for you, and she will present to you later. So I know you've already done it in the lab, but let me give you a quick recap about qualitative analysis. So roughly speaking, you're interested in determining the chemical composition of a sample. Could be a specific ion or a specific functional group. In inorganic chemistry, it's mainly specific ions, but yeah, in a pharmacy or analytic laboratory, you can perform qualitative analysis with three things in mind. So you're either aiming to get information about the composition of the sample, the purity of the sample, or whether it contains impurities, and to find out whether your allowed impurities within a certain concentration limit. But as you know from the wet lab, this exercise deals with the first point on the list, so the determination of the composition of a sample. I also included some information about this in the Google Colab notebook that you will be sent later. And of course, you also have your practical script that you can take a look at. So since it's some kind of detective work that you have to do, I figured I call this Python project Ion Detective. So you're in the role of being a detective. And your goal is to figure out what kind of ions are in your sample probe. So speaking a little bit in programming terms, what's behind this? So Ion Detective is a Python class. I don't know if you've dealt with this in the introduction, but don't be scared. Roughly speaking, what a class can do is it can be initialized like this. So you just call this class with the brackets behind and save it in some kind of variable. And with this variable, you can do many things. It saves additional variables inside or certain functions, as you will see. So everything we will do will use this kind of variable that you use to initialize your class in. So once that's initialized, you can start calling a function that's inside this. So to do so, you can write ion.generate probe. What this does is it generates a certain ion probe randomly for each of you, and it takes as arguments the ion type. So it could be anions or it could be cations, and it takes something that's called a seed. So I don't know if you are aware of this, but producing randomness in a computer is not so easy as it sounds, because in a certain way, randomness in a computer is also some kind of deterministic. So in case to make this thing reproducible for each of you, everybody of you gets a certain number assigned, and depending on this number, the probe that's generated for you will be fixed, so that we know what probe you have, and everything's going to be fine. Once you've done this, it will print the text below, probe is generated, now perform some experiments. Cool. So to see what experiments are available, you can call a function that's called list anion tests, and don't be scared. All these functions and some explanation for all of them, it's all in the notebook, so you can follow through and read through it again, and you don't need to panic and write everything down here. So everything will be completely documented in the notebook. So everything's going to be good. So you can call this function. In case you call a function with this class, you always have to put this dot here and then put the function here. So list anion tests will print you a list of all the tests you can perform: test acetate, test carbonate, test nitrate, whatever. These are all the ions that can be in your composition and that you need to find out. So as a test, I performed an experiment to test for acetate. And what this will do, it will print below the instructions that are exactly like this in your practical script. So it's identical to the things that you would do in the wet lab, but yeah, just in a virtual way, just written, so with less work. So it's good for you in this case. But the thing is, occasionally it will ask you what to do, because the program is stupid and it doesn't know, and it wants to know from you, how much substance do you want to add? And then it opens a comment prompt and you can input something. In this case, it's asked how many times more substance do you want to add than something else. And this description is exactly like this in your practical script. So you basically, while you do these exercises, you need to have your practical script next to you, and you need to look up what you want, what you need to do, exactly like you would need to do in the lab, because otherwise you mess up and things happen, as you may see on the next slide. So to summarize some important information. So after this call, you all will get an email, contains your specific seed number next to your email. So please, once this email is sent, please check if you all have a seed number. In case you're not in the list or something else happened, just contact us either on Slack or per email. And the seed number is really important because it will generate a unique ion composition for each of you, and we have everything saved on our servers. So just make sure you use this number. But in case you want to test and try a little bit out with this library, you can also use a number between 1 and 100 just to test an experiment. And I also implemented a function that you can use to self-evaluate in case you want to be sure for these kind of numbers. It will obviously not work for the seed numbers that you will get sent by email. This I already mentioned, so you need your practical script. So just like in the real lab, the software will ask you specific questions and you have to answer them correctly. Otherwise, the experiment maybe blows up, which can actually happen. So otherwise, in case you answer wrong, this software has a low chance to give you maybe a false positive or a false negative. So just imagine you're in the lab and you're adding way too much of one substance, or you're adding even the wrong substance and you're doing a wrong step, you also get a wrong outcome. So you really need to read what you want to do and apply it also here in the software. So that's about this exercise. At the end, I also included a voluntary exercise, which is not graded, but I think it would be really great for all of you to do this, just to train your programming mindset. Because if you think about this exercise from a programming perspective, you call an experiment and it either gives you a positive or a negative result. So in programming terms, it's either true or false. So basically what you would like to do is you would like to automatize everything. So you don't need to spend an hour in front of the computer and type in everything. If I give you a different seed number, you just want to press one button and it always gives you the correct answer. So in this case, I wrote another class which skips all the manual input, so it will not ask you anything. It just gives you true or false as an output, and your task is it to write some code that always gives you the correct answer for whatever random composition I give you. And yeah, so basically it's maybe 3 or 4 lines of code, and I think you all would benefit greatly from trying a little bit to solve this problem. So are there any questions so far? If not, that's it from my side. And I think we do a quick switcheroo and Book will take over, right?
Yeah.
Cool. So doesn't seem so. So that's it from my side. Can I exit stop share?
Let me just try. Google Chrome. Sorry, I have some security. One moment. I have to let the thing access my screen. Okay. Share screen. Oh God. Okay. Sorry.
Maybe it wasn't such a quick switcheroo as I thought.
Okay, I'm not actually sure I'm going to be able to share the screen without reopening Zoom. So would you mind sharing the screen and I'll just tell you when to click? Sorry. Great, thank you. Okay, so the second part of the exercises has to do with a part of the experiments that you didn't actually do yet. So it was the titrations. And if you read the practical script, you will have seen that there were several chapters of titrations. So there were acid-base titrations, and then there were some others like complex metal titrations, like more complex versions. But for the programming exercises, we'll only be looking at acid-base titrations, as I think there's kind of enough to work with there. So in an acid-base titration, I've kind of tried to indicate what you would do in a lab in the left diagram. Yes, thank you, Dominic. So you would put, you would fill up your burette, which is the tall, narrow glass burette, with a base of a concentration that you know. So you take it from the bottle where you know it's 2 moles per decimeter cubed. So you know exactly the concentration of the base that you're dealing with. And then in the conical flask, which is the glass container at the bottom, you put an acid usually of an unknown concentration. So you could also flip the setup so that the acid was in the burette and the base was in the conical flask. But in the exercises that we'll be doing, the acid is in the conical flask and the base is in the burette. So you know the concentration of the base and you're trying to determine the concentration of the acid. And this is quite a standard procedure. And on the right, I've put some titration curves. So these are curves that you can either manually plot, or in these exercises we'll be plotting them with Python. They show how the pH changes as a function of the volume of the base you're adding through your burette. So there are basically 4 different types of titration curve. So the first one shows a strong acid, strong base titration. So that means the pH starts very low because it's a strong acid. So the pH is something like 1. It very slowly increases as you add the base. Thank you, Dominic. And then it shoots up very rapidly at what is called the end point of a titration, because you finally have enough base to neutralize your acid. So at the point where you have exactly equal amounts of the two, your pH will be around 7. But then if you add any more base, the pH quickly increases to the pH of the base. So that's a strong acid, strong base titration. But if we go to the second diagram to the right, yes, thank you. This is a weak acid with a strong base. So the pH starts off more like a pH of 3. It increases more rapidly, and the pH of the end point is higher than 7. It's something like 9 or 8. And then again, it flattens out to the same pH of the strong base. So then on the bottom left, we have a weak acid, weak base. So this is actually quite undesirable for a titration, because as you can see, it's pretty difficult to distinguish the end point. And that's because both the acid and base have such a weak effect that there is a very negligible increase in the pH, so it's quite hard to read. So you actually typically don't do that in an experiment. And then on the right, this is relevant because you'll be looking at one of these. So sometimes you have an acid which has multiple protons. So for example, H3PO4, there's more than one hydrogen there, there's more than one proton. So there will be several deprotonation steps. So every time you have a neutralization event, like an acid-base neutralization, there's a deprotonation. So here you can see there are actually 2. So you see 2 of these inflection points where, they're exactly the same as they were in the previous plots, you just have 2 of them. So that indicates the pH rapidly changing at 2 different pH values. So here they've also indicated that there are 2 different indicators. So these indicators in an experiment will tell you where the endpoint of your titration was, because they will usually change color at that inflection point. So obviously in a simulation, we won't see a real color change, but in an experiment, that's what we would expect. Can we go to the next slide? Thank you. So the second exercise is a simulation of the actual titration experiment. So this is supposed to kind of mimic the setup that we saw with the burette and the conical flask. So normally in an experiment, you want to be very careful with how quickly you add the base from the burette, because the endpoint, as we saw in the plots, happens very quickly. So if you're too fast, if you add the NaOH or the base too quickly, you'll miss the endpoint. So I've written some code for you on a Google Colab notebook where it basically asks you to continue adding your base until we see a color change. So I've written here, so this is actually a screenshot of the real exercise. You basically either enter the word flow or the word drop to say that you want a rapid flow of your liquid, or if you want to do it dropwise, so drop by drop. So just like in a real experiment, if you do it dropwise, you obviously have much better control of what's going on, but it will take much longer. So typically in an experiment, if you're impatient like I am, you'll just flow the liquid, and then, oh no, you'll have overshot the endpoint, and yeah, you'll kind of be a little bit imprecise in your titration. So usually in practice, you should kind of opt for being cautious somewhere in the middle. So because if you did do it dropwise, it would be very, very slow. But if you keep flowing through, then you will overshoot your endpoint. So you can kind of experiment with that just like you would in an experiment. Can we go for the next slide? Okay, so then once you've done exercise 2, the next exercise is to actually plot one of these titration curves. So it will be for the same titration as the one that you simulated in exercise 2. So the example I've got here is not the one that you want to be producing. It's a different example. So I think it's NaOH with HCl, because you can see there's one pH change. So this code example that I've got on the right is also on the Colab. So you've got an example of what you're trying to do. It's quite similar in concept to what Dominic just described. So there's a class that I have written for you, a titration class that has a number of functions and attributes. So you initialize it with a base and an acid. So in the previous lines, I will have defined what the base and the acid are. And then you also need some information about the volume, so how much you've got in your conical flask, and the maximum volume in your burette that you're going to be titrating. Then you tell the class instance these values. So I've set the volume with that volume that I defined. And then everything after that basically has to do with the plotting. So I don't know if Anders asked you to do any plotting in his part of the course, but plotting in Python is super useful because you can make really nice plots with hopefully not too much difficulty. But so I've just defined some things to do with the precision. So how many points I want. So usually the more points you have, the smoother a plot you'll have. If you're lazy and you put something like 10 points, you might miss that sharp increase. So you can also play around with that. Then I define my X and Y values. So it's a plot of a Y value against an X value. And then I actually make the plot. So this uses a package called matplotlib, which is the package that you always use for plotting in Python. So it also initiates an instance of a plotting class, which then has functions to plot. So you just plot X against Y. I've chosen that I want it to be red because I thought it would be easier to distinguish against the black. And then I've put some labels on the axes so I remember what I'm plotting. And I've also put a grid so I can read more clearly where the inflection point is. So obviously not all of these things are essential. Plotting in Python is super adaptable. Like there's a lot of different things you can do. So you can mess around a bit with this if you like. The actual assessment will have to do with whether you plotted the correct thing. So I'm actually looking for, at a specific volume, does that correspond to the inflection point, and is it the correct pH? So you don't need to worry too much about making it pretty. It's just whether you did the right thing. but I think it's a good exercise to try out plotting in Python. Okay, next slide. So I already mentioned a little bit the assessment, but something that's worth mentioning is that all the exercises are graded together, because for the previous exercises in the lab, we normally did them, you put in your marks at the end of each section, but here you have to put them all in together. So kind of write down your answers and then save them. And then you go to this link. I'll send you all of this in an email, so you don't need to write it down. But you go to this link and you put your email address, and you, again, as before, make sure that it's your email address. And then you enter your answers. So exercise 1 was the same as it was in the experiment. So you get 3 points for anions and 3 points for cations. So for a total of 6 points. And then in exercise 2, so that was the titration experiment, I ask you 3 different questions about your titration. So the first one is a calculation that you do. And then the other 2 have to do with this flow drop, like whether you overshoot the endpoint. And so there's 3 points there. And then exercise 3, the plotting exercise, as I mentioned, I'm just looking that you plotted the correct thing. And if you plotted the correct thing, you'll automatically get 3 points. So in total, it's out of 12. And as before, you need 50% to pass. So you want 6 out of 12 points. Okay, what's on the next slide? Yes, so in summary, I'll send you an email directly after this call with all of the information. So the Google Colab links, the seed numbers, basically everything that we've gone through in this presentation. So the deadline for the exercises is this Friday at midnight. So I didn't understand whether that means it's like the end of Friday, like the evening of Friday, or Thursday evening. Can someone clarify that?
Yeah, end of Friday.
End of Friday. Okay, so basically just submit it before it's Saturday. And if you have any questions, I don't know if you used the Slack channel for Anders's course, but there's a specific channel on there for the Pharma practicum, so you can either discuss amongst yourselves or ask us questions. You can also send us emails. Does anyone have any questions now? As always, you can post in the chat or you can unmute yourself.
Maybe a comment for the first exercise, the multiple choice. If you mark something wrong, it gives you -1 point.
That was
Right?
the same as before, yeah.
Yeah, so guessing is not a good idea.
I actually tried guessing to see if it worked and I got -20%. So yeah, I wouldn't recommend guessing. Okay, doesn't look like there are any questions. But yeah, please don't hesitate to ask any before Friday on any of the media that we mentioned. Oh, sorry, chat. What is with the points of the first? Yeah, so they will still count. Heini, do you know this? The points they got from the first experiment they did, how is that going to weigh into their final grade?
I think they will be counted as well. Maybe the total of all, so the lab and the pharma, the virtual course will count. But I'll have to look at it with Professor Anatol.
Yeah, but they're definitely counted because we don't want to neglect your work. So it's probably the 12 that we mentioned plus the 6 from the exercise that you already did, I think. Okay. If there aren't any more questions, then good luck. Hope you enjoy and learn some more Python. Okay.
All right, that's it. Thanks, everybody.
Yeah, thank you very much for the nice presentation. Bye. And good work, actually.
Thanks. And thanks for trying, for testing.
Okay.